Yes. Am I audible? Please give me thumbs up. Then please give me thumbs if I am audible. Hi. Yes. Yes. I hope my audio is clear for you. So, welcome to GoScore Learning. We are the fastest growing edtech in GCC. Our aim is to provide education for all. So, my name is Rahul. I am from Physics Department of GoScore Learning. So, here I am coming with the Chapter 9 of grade 10 science, which is light, reflection and refraction. So in last part, the part 1 video of this class, we have already discussed about the preliminary things about reflection, and today we are going to discuss the second part, which is we will be discussing some numericals and problems related to reflection, and then we will be moving to refraction part. Okay, so I will be winding up this chapter in third session, 3 sessions, and today's session will be including the mirror part exclusively and numericals from mirror part and the lens part. Okay, so you will be able to know how to complete the ray diagram and all using some tricks and tips to complete the ray diagram. So stay tuned with the classes. So we'll be make learning easy for you. Okay, so today as we wind up in a numerical session in last class, today I'm directly going to the second question, so next question, which is related to mirrors. Okay, so we are running for the day 20th of February 2025, like when we are calculating, just like couple of 60 days are remaining for us. Okay, so almost, so the final countdown is already started, so we are running with a nice pace. So stay tuned with GoScore Learning. We'll be making every science and maths chapters easy for you. So there will be live in every week, Monday, Tuesday, Wednesday, Thursday, every day you'll be having live session from GoScore Learning with the teachers. Okay, so today I am going to moving with the first question for today. If the image formed by the mirror for all portion of the object placed in front of it is always erect and diminished, what type of mirror is it? What type of mirror is it? Okay, so it is a direct question. It's a direct question. Can you answer? Is there anyone knows the answer? Definitely my kids knows the answer. Like, put your comments on the comment box. Okay, put your comments. What is the answer for this question? What kind of mirror it is? Okay, we know that there are 3 types of mirror: plane mirror, concave mirror and convex mirror. Plane mirror, concave mirror and convex mirror. As you know, concave mirror gives both diminished and enlarged image along with same sized image, but there is one mirror which is convex mirror, which always gives diminished image, right? Diminished virtual erect image. Convex mirror is the mirror, convex mirror is the mirror which always gives diminished erect image. So that's why for irrespective of the all the position in which the object is placed, convex mirror gives diminished virtual and erect image. So convex mirror is the answer for this question, right? Easy question, but it's like 1 mark question. Okay, so then name the type of the mirror. Name the type of the mirror used in the following situation. Okay, so here we are going to discuss with the application of mirrors. Applications of mirrors that we are going to discuss with. Okay, so it's Miss Nabiha. Okay, hi sir. Okay, Nabiha, hi. Like, so if you know the answer, just better if you are putting on the comment box, so that I can easily move to next question. No need to explain because my kids knows the answer. Yes. Okay, so name the type of mirror used in the following situation, which means the question is based on the applications of mirrors. Okay, headlight of a car. What kind of mirror we need to use? The plane mirror, concave mirror or convex mirror? What kind of mirror we need to use? What kind of mirror we need to use? Okay, so we need to use concave mirror here. We need to use concave mirror there. Okay, then next one, side or rear view mirror of vehicle. What kind of mirror we need to use in side view mirror? You know that rear view mirrors of vehicle is using what kind of mirror? Convex. Okay, so what is the reason for convex mirror is being used as rear view mirror? You know, plane mirror is also giving erect image, virtual image every time, but convex mirror have that property which has wider field of view. That is the reason because convex mirror is being used as rear view mirror of vehicle. What is the term? Field of view. Field of view. Field of view is more for convex mirrors. Field of view is more for convex mirror. That's why they are being used as rear view mirror of vehicles. And if this is a question asked for 1 mark or 2 mark, you cannot precisely write this just this one. Field of view is more for convex mirror. That is not enough. You should write 2 more points like in such a way that like first point you can write with irrespective of the position of the object, convex mirror always gives erect, virtual and diminished image. Okay, so irrespective of the position of the object, doesn't matter whether you are placing the object. So always you get, using a convex mirror, you get erect image, virtual image. Erect image is always virtual. We have the code EV, sorry, EV and IR. What is EV stands for? EV stands for erect image is always virtual. IR stands for inverted image, always real. Okay, so it's applicable for both lenses and mirrors. Okay, not just it is exclusively for mirrors, it is also applicable to lenses. Erect image is always virtual, real image is always inverted. Okay, so here erect image, obviously it is virtual image and diminished image. Convex mirror is the mirror which is giving erect, virtual, diminished image irrespective of the position of the object. Okay, and second point you can write, field of view is maximum. Field of view is maximum for convex mirrors. That's why it's being used as the rear view mirror of vehicle. So that's the most repeated question that we can ask from this mirror portion. Okay, then solar furnace. I think some of you have confusion with what is solar furnace. Okay, solar furnace. Okay, so it's better if you are just googling about solar furnace, you will be getting image. So rather than I am saying about it, it is better. His solar furnace means solar cooker, which is using sunlight to cook. Okay, so if I am saying sunlight to cook, it is better if you are saying getting the image, so you'll be easily getting things. Okay, so once you get the image, so here because of copyright it is, I can't simply give the image over in the slide. Okay, so then solar furnace which is using, is there anyone who can give the answer for this question? Solar furnace is using concave mirror. Okay, solar furnace is using concave mirror. Then dentist mirror, you know that dentist mirror is also, dentist mirror is concave again. Dentist mirror is concave. Okay, for what position of object? The object should be placed within the focus of a concave mirror, then only you will be getting a enlarged virtual image. Okay, for dentist case, the concave mirror is used, but the object, what is the object in the case of dentist mirror? Our teeth. Our teeth are the case. Yeah. Okay, so our teeth are the object over there. So that object, our teeth should be placed within the focus of that concave mirror, so that you will be getting virtual, erect and enlarged image. So here you will be getting virtual, erect and enlarged image in the case of dentist mirror. Okay. Okay, so I'm moving to next question. Why do we prefer convex mirror in the case of rear view mirror of vehicle? Just now I have explained, right? Okay, just now I have explained why convex mirror is being used as rear view mirror of vehicle. What is the reason? What is the reason for which convex mirror is being used as a rear view mirror of vehicle? I have mentioned 2 points. What is the first point? It, irrespective of position of the object, it always gives erect, virtual and diminished image. Okay, irrespective of position of the object, convex mirror always gives erect, virtual and diminished image. Then second point is, this is an important point. It has large field of view. It has larger field of view. Okay, so you know there is no point to explain what is field of view. My kids already know about it. Just I recall the point. That's it. Okay, so I want to mention, even to the question, you know the answer. Large field of view is the reason for which convex mirror is being used as the rear view mirror of vehicle. But other than that, it is better. It will be creating an impact for your answers if you are writing erect, virtual and diminished image. Okay, So always try to write in points for this kind of question instead of like a sentence, long sentences. It will be help you for getting points, because in CBSE marking scheme they will be giving marks for the points. Specifically, if the child who wrote this much of point will be awarded with this much of mark, like that the marking scheme works. So it is not about the sentences. There is no, it is not like English exam, social science exam. You don't want to explain in a long paragraph. Better if you could write the answer in point. Okay, underline the important thing. So here these two words are there, so you can just give as points, first point, second point, that's it. Okay, that will be make your answer perfect, and it will be creating an impact on the teachers of yours answers. Okay, so where should be an object placed in front of the concave mirror of focal length of 20 centimeters, so to obtain 2 times magnified real image. So in the last class we have already did that kind of problem. Okay, one second. Okay, so listen, related to mirrors, mirror equation, there are two kind of numericals is being asked. Okay, first kind of is problem is just like they'll be asking for f u v. Out of these three, just two things will be given. Okay, either a or u will be given. You can find v. So that is pretty easy, like using mirror equation you can easily calculate. The other kind of method is just like they'll be provided with u or v. They'll be provided u or v, and magnification is also provided. Magnification will be also provided. So using that, you need to find the things which is asked in the question. Either u or v, and magnification will be also provided. So magnification will be provided with it can be real or virtual, depending upon that you need to choose the sign. Okay, so these are the two kind of questions that is asked from related to numericals, related to mirror equation numericals. Okay, so these are the two kind. First set is just like f, u and v. That is very common and it is easy to answer. You guys know about it. Just the thing is you need to aware about new Cartesian sign convention. The second set is just like either u or v will be given, and along with that magnification will be given. So that is it. So here the question, can you comment whether it is the first type of question or second type of question? First type or second type? Set 1 or set 2? Okay, so here it is. What is given? Focal length 20 centimeter. So here, okay, f can be also given over there. Using f also we can find it. Okay, so f is also given over there. So f, u or v, anything will be given. Out of these three, any one will be given, and magnification also given. So we at least we should need two data, either f, u or v and m, or out of these three any two things will be given. Okay, so here this type of question is coming from the first session, right? So like first type of question it is here focal length is given, just a second. Okay, focal length is given. What is the focal length? Focal length of concave mirror 20 centimeter. As it is a concave mirror, we should take it like negative 20. Okay, then so where should be an object be placed in front of a concave mirror of focal length 20 centimeter so as to obtain 2 times magnified real image. So m is equal to 2 times magnified, as it is real image. Real image magnification is tell me, real image magnification is, yes, real image magnification. Sir, I have my exam tomorrow, please help me this question. What is 2 into 2? Who is that? 2 into 2 is asking. Just kidding. Okay, JK. Okay, so m is equal to 2. As it is real image, it is minus 2. Okay, is there any unit for magnification? No, there is no unit for magnification. Okay, so m is equal to 2. So we have m is equal to minus v by u. M is equal to minus v by u. So we can substitute. So just follow these steps. This helps you to find the first type 1 of question. Type 1 question you can solve using this method. Okay, so m is equal to minus v by u. So here it is given minus V by U is equal to minus 2, because M is equal to minus 2, right? So for mirrors it is minus V by U, it is mirror, right? Yeah, it is mirror. Okay, so which is equal to V by U is equal to 2, which implies V is equal to 2U. U taken over here, V is equal to 2U. Okay, now the second stage for finding this answer for this question, use we have 1 by F is equal to 1 by V plus 1 by U. It is mirror, so 1 by V plus 1 by U, 1 by V plus 1 by U. So 1 by F is equal to 1 by, so instead of V substitute 2U, that is the step, plus 1 by U. Okay, so 1 by F, what is 1 by F here? Minus 20. 1 by minus 20 is equal to, so we can take the LCM, right? So 2U, so here multiply 2 and, okay, so 1 plus 2 divided by 2, multiply with 2 here in the bottom and denominator. So 1 into 2 divided by U into 2, so 2U in the denominator. So 1 by minus 20 is equal to 3 divided by 2U. Okay, so we can take this 2U to LHS, minus 20 to the RHS. Okay, that is the next step. Okay, so we can take it like 2U is equal to minus of 3 into 20. Okay, so 2U is equal to minus 60. U is equal to minus 60 by 2, which is minus 30 centimeter. So you have got, what is the question? Where should be object be placed in front of a concave mirror of focal length focal length of 20 centimeters, so to obtain 2 times magnified image. So you have got U is equal to negative 30 centimeter. Okay, so you are not supposed to, you know that it is object distance. It is object distance which is asked. Okay, so you have got the object distance. Where should be the object should be placed in order to get 2 times magnified image, right? So it is object distance which is asked, but you are not supposed to stop your answer by writing U is equal to minus 30. You should write the object should place. Okay, so this is where the students are lagging. So you should write this. You should write this. The object should be placed. The object should place 30 centimeter from the mirror. Okay, so negative 30 is like, as you know, it is about no Cartesian sign convention. The object should place 30 centimeter from the mirror, so that it will be producing 2 times magnified image. It will be producing 2 times magnified image. Fine. Fine. So you got the answer. So here V you will be getting 2U, so 60. So 60 V by U, 60 by 30 you will be getting 2. So your answer is correct. Could you follow? Could you follow? Is it easy? So remember, for the set, if F, U, V, out of these 3, if 2 is given and it is easy for you to find the answer. I have seen most of the students are facing stuck with this kind of question. F or U or V, any 3 will be, out of these 3, any one will be given along with its magnification. Okay, most probably focal length is going to given. Most probably focal length is going to given. So focal length along with magnification, this is the method you are supposed to use, both in the case of mirrors and lenses. But be aware about, like in the case of mirrors you are supposed to use magnification is equal to minus V by U. In the case of lenses it is like V by U. And here in the case of mirrors it is 1 by F is equal to 1 by V plus 1 by U. In the case of lenses it is 1 by V minus 1 by U. So that changes you should make accordingly. Okay, so that it is easy to find. Okay, could you follow? Easy, right? Okay, let's go on. Okay, consider the following diagram in which M is a mirror and P is an object and Q is the magnified image formed by the mirror. State the type of mirror M and one characteristic property of the image Q. Okay, characteristic property means whether it is inverted, real, magnified, enlarged, like that. Okay, so characteristic property we can write. So already it is magnified. enlarged. That property is given. So other than that, we should mention it is whether it is a real or virtual image. Okay, M is a mirror which is given, right? Okay, so here you have got Q is the image form, so Q is enlarged. So no need to think furthermore. You know that there is just one mirror which is capable of giving enlarged image. There is just one mirror which is capable of giving enlarged image. What is the type of mirror which is capable of giving enlarged image? This is just by concave mirror. Concave mirror is the only mirror which is capable of giving enlarged image. Okay, so here it is concave. M is concave. So your answer should be, so which M is a mirror and P is an object and Q is the magnified image form. Okay, state type of the mirror. So your answer should be type of the mirror. Type of the mirror is concave. Concave mirror, or as it is type of the mirror it is asked, you know that concave mirror is a converging mirror. Converging mirror. So as it is not named the mirror or type of mirror is not asked. So yeah, type of mirror it is asked. So you should mention it is converging mirror which is concave. So if you are writing concave mirror also you will be awarded with a mark, but better if you are having that kind of confusion, if you are, it is better to write both concave mirror, it is a converging mirror. Concave mirror which is a converging mirror. Okay, and converging mirror and characteristic property of the image Q. So you know that properties, characteristic properties of the image formed. You know that when the concave mirror is giving enlarged image with this form behind the mirror, which is virtual. Here mirror, concave mirror is like this, right? So the image is formed behind the mirror which is erect. So virtual image, this erect image, this is enough. Any characteristic property, right? One characteristic property which is asked. So the characteristic properties of the image formed are, which is virtual and erect. Virtual, erect and enlarged. Virtual, erect and enlarged, and image is formed behind the mirror. Image is formed behind the mirror. Okay, could you follow? Just 1 second. Sorry, am I audible right now? Let me check. Am I audible? Yes. Okay. Okay, we can move to next question. Okay, so AB and CD, two spherical mirrors from part of a hollow spherical ball with its centers O as shown in the diagram. If arc AB is equal to 1 by 2 of arc CD, what is the ratio of their focal length? Can anyone answer for this question? Can anyone answer for this question? Can anyone answer for this question? Okay, so here both AB and CD are part of same sphere, right? So as they are part of same sphere, the length of arc doesn't matter. It is depend on the aperture of the mirror. So that doesn't matter. AB and CD having the same radius of curvature. So R is same. Radius of curvature is same. R is same. So we know that, sorry, R is same. So we know that F is equal to R by 2. F is equal to R by 2. So which implies both AB and CD have same F, same focal length. The concept is clear? Just 1 second. Yeah. Is the concept is clear? It doesn't matter. The arc length is different. Arc length we can comment on like aperture of the mirror, but here as AB and CD are part of the same mirror, same sphere, not same mirror, my mistake. Okay, as they are part of same sphere, so the radius of curvature is same. The radius of curvature is same only, right? The radius of curvature is same. So if the radius of curvature is same means R is same means F is equal to R by 2. So focal length is same. So arc length doesn't matter. Length of circuit doesn't matter. Okay. So ratio of the, what is the ratio of the focal length? So you should write ratio of the focal length. Ratio of F is equal to 1 by 1, which is equal to 1. Ratio of the focal length is equal to 1 by 1. Clear? Ratio of the focal length is 1 by 1. State which of the two mirrors will always form virtual image of an object placed in front of it. Okay, from this diagram it is clear that AB is a convex mirror and CD is a concave mirror. What is the question? Which always forms virtual image. So you know that concave mirror is capable of giving virtual and real image. Concave mirror is capable of forming virtual and real image, but when it comes to convex, it always forms virtual image. So when it comes to convex, it always forms virtual image, virtual diminished image. So that we can take it like AB, mirror AB forms, mirror AB forms virtual image every time. Always forms virtual image is by mirror AB as it is convex, So state which of the mirrors will always form virtual. It is not asked why. So all of you, every time you should read the question just in such a way that whether for some of the question, not just answers, they will be asking why. So if you are skipping that why part, if you are not writing the answer for that reason for that question, or sorry, reason for that answer, or if you are skipping the why part, what will happen means you are going to lose the marks. If it is a 2-mark question, 1 mark is going to be the answer, precise answer for the question, and the 1 mark is for the explanation. If you are not writing the reason for that answer, you are going to the half of the marks, total marks, half of total mark will be gone. Okay, so which you need to care of. Okay, so read the question properly. Okay, next one. Okay, so Neha visited a dentist in his clinic. She observed that the dentist was holding an instrument fitted with a mirror. So what kind of mirror it is? You know that dentist may be using so many mirrors, and we are not like studying BDS. So how can we know the name of the equipment? But you always think like in our syllabus we are mentioning about dentist in the first chapter, or this chapter light reflection and refraction only about just for one thing. What is that? Dentist mirror. So what is that dentist mirror we know about? Dentist mirror is a concave mirror. Dentist mirror is a concave mirror. Okay, so change the nature of this mirror and reason for its use in the instrument used by the dentist. You know that it is concave mirror. Where it is being used? When the object is placed within the focus of a concave mirror, when the object is placed within the focus of a concave mirror, it is producing an enlarged erect virtual image. So that is useful for the dentist to examine our teeth. That is useful for the dentist to examine our teeth. That is the reason. So when the object is placed within the focus, what is meant by within the focus? With the focus means object placed between F and P. When the object is placed between F and P means focal length and pole. That is what is meant by object placed within the focus. You got it? Could you follow? Yes. Okay. So here is answer. The nature of this mirror is the concave type or the converging type, and the reason for the use in the instrument used by dentists is to obtain an erect, magnified image of teeth. Then only the doctor can examine it. Okay, so a concave mirror gives the dentist a magnified reflection of our mouth. This is not mouth, usually you need to examine our teeth especially. Okay, that is fine. Okay, so this means that image in the mirror is big and brighter, and for the dentist it is easier to see. Otherwise it's very hard to observe our teeth, upper teeth. Okay, so for the same he can use that dentist mirror which is small and will be giving and brighter enlarged image version of our teeth. Okay, so another positive point of using concave mirror is that the image in the mirror is inverted. It is not inverted, erect. Okay, then radius of curvature. This is a previous question again. Radius of curvature of a concave mirror is 50 centimeter. What is the focal length? What is the focal length? Okay, so is there anyone who is capable of answering this question? If you are careless, there is chance for losing 1 mark. If you are careless, there is a chance for losing 1 mark. What is the radius of curvature? Radius of curvature is given. R is equal to what is R? Just hurry up, my kids, answer it. What is R? Which is the given things. R is equal to, those who are writing 50 centimeter are going to lose mark because it is minus 15. Because it is concave mirror. Because it is concave mirror. We have explained in last class. Concave mirror, radius of curvature, focal length negative. Both for concave mirror and lens. For cave it is negative. For cave it is negative. We mentioned in last class, right? Cave negative. What negative? What kind of negative? Like radius of curvature and focal length of a concave mirror and concave lens is negative. So radius of curvature and focal length of convex mirror and lens is positive. So that is according to new Cartesian sign convention that you are already aware about. Okay. So when here R is equal to minus 50 centimeter, what is the focal length? We know F is equal to R by 2, this is equal to minus 50 by 2, this is equal to 25, negative 25 centimeter. So those who are simply writing 25, is not supposed to get mark, is not going to get mark. Okay. So it is important to precisely write the answer with the sign. So here, if they are emphasizing, right, what is the focal length of the mirror, use according to new Cartesian sign convention, definitely most of you will be answering like negative 15, sorry, negative 25, but that's not the case here. Even though as the concave mirror is mentioned, it doesn't matter whether they have emphasized emphasis for using new Cartesian sign convention or not. Definitely you should go with it is negative 50 is the radius of curvature and negative 25 is the focal length of the mirror. Okay, fine. So that is pretty important. Okay. Then, lengthy question it is. See, a concave mirror is used for the formation of different position of an object. What inference can be drawn about the following when object is placed at the distance of 10 centimeter from the pole of a concave mirror of focal length 15 centimeter. Okay, so here what are the details provided? So we can take F is equal to, while you are writing focal length is given, F is equal to 15 centimeter. Check whether it is concave or convex. That should be your preference while you are writing, where you are attempting any questions related to mirrors and lens, numerical related to mirrors and lens. Your first preference should be giving the sign of the given data according to the type of the mirror and lens which is given. Okay, here it is concave mirror is given. So concave, it is concave. Concave mirror it is. So negative 15. Okay, one more thing, 10 centimeter. What is 10 centimeter? Object is placed. U is equal to, U is always negative. Doesn't matter where it, what kind of mirror it is, what kind of lens it is. U is always negative. U is negative. U is negative. Object distance is negative. Always negative. Okay. So position of the image, we need to find V. So what kind of position? It is very easy. Okay. So I don't want to explain a lot. I will directly write the formula. 1 by V is equal to 1 by F minus 1 by U. 1 by minus 15 minus plus 1 by 10 plus 1 by 10, is it right? Okay, so what is LCM? LCM we can take like 30. So 30 means minus 2 by 30 plus 3 by 30. So which is equal to minus 2 plus 3, 1 by 30. 1 by V is equal to 1 by 30. So V is equal to 30 centimeter. Very easy. V is equal to 30 centimeter, right? V is equal to 30 centimeter. Okay, I know I have covered a little bit. Okay, even though now you can see the answer, right? Okay, so V is equal to 30 centimeter. This kind of problems is, there is nothing to explain. So our kids are able to deal it with within fraction of some time. Okay, size of the image. Size of the image means object height is given. Okay, so here we need to find magnification. Size of the image is definitely will be related to magnification, right? Okay, so M is equal to, as it is mirrors, minus V by U. Minus V by U. Okay, so here what inference can be drawn about the following data? So here it is height of the image or height of the object, nothing is given. So size of the image you can comment only on the basis of magnification. If magnification is greater than 1, modulus of magnification is greater than 1, we can comment like it is enlarged. If the modulus of magnification is less than 1, we can take it like it is diminished. If the magnification, modulus of magnification is equal to 1, we can take it is same size. Okay, so here m is equal to minus v by u. So minus v means minus 30 divided by what is u? U is minus 50. Sorry, minus 10. Okay, so it's equal to 3. So magnification 3 means we should take the modulus of magnification. This is what is modulus of magnification. Modulus of magnification. So those who are in like maybe those who are in 11th grade maybe watching this video, they know much pretty about those PCMB students or PCM students know the definition of modulus. But for grade 10 kids, I don't want to explain in that much extent. You can simply take it like modulus means just avoid the sign and write the number. If you are getting negative 3 and modulus of negative 3 is 3. If you are getting positive 3, modulus of positive 3 is not negative 3, you should avoid the sign, write the number. Okay, so there is an exact definition, and for modulus it is equal to like there is a function for it. So I don't want to explain it here. So here modulus of magnification means modulus of 3. Modulus of 3 is 3 itself, just the number you can take. So here modulus of magnification is greater than 1 as it is enlarged image or magnified image. Enlarged image is enlarged. The image format is enlarged. Okay, so you should write the answer for the first question, question A, and for question B. Okay, I will place it here. Okay, size of the image. So for size of the image, should write B. M is equal to minus house. Here we can write right. Okay, B. M is equal to minus V by U. So M is equal to 3 that you have got. So image is magnified. Magnified. Okay, image is magnified. Okay, so because height of the object is not given, so only we can comment about it is magnified image. Okay, anything else is given? Nature of the image. Nature of the image as it is, magnification is positive. Magnification that you have got is positive. This virtual image. Magnification is positive. This virtual image. So as you know, M positive, it is virtual image. M negative, it is real image. It is real image. Okay, so if modulus of magnification greater than 1, it is enlarged image. Modulus of magnification less than 1 is diminished image. Here magnification you have got positive 3, so it is virtual image. So answer for the third question. C question is nature of the image is like yeah, virtual and erect. Nature of the image formed is virtual and direct. Nature of the image formed is virtual and direct. Okay, easy, right? And one more, draw the labeled ray diagram to justify your answer. Okay, so how can you draw the labeled ray diagram? So first of all, just understand what kind of mirror it is given. Concave. So mark it focal length and radius of curvature. Every time I have seen some of students are drawing the ray diagram without having an awareness about. If you are marking, okay, I will draw in another page, that will be better. Okay, so if you mark the concave mirror like this, okay, so if this is your concave mirror, next time you are going to draw the principal axis, right? You are going to draw the principal axis. Okay, so if you draw one second, yeah. So if you draw the principal axis, this one will be your pole. Okay, so then you take a scale and measure a certain distance. Okay, center of curvature, if you are taking the radius of curvature as 10, so 10 centimeter from it, you can mark C, center of curvature. Center of the arc, you can mark C. Okay, that the point in which you have placed the compass needle, you can take C. Okay, if it is 10 centimeter, mark a point at 5 centimeter. Mark a point at exact midpoint, that is for principal focus. So you should follow that one. If you are not following that consideration or that criteria, not consideration, if you are not following that criteria, you are not going to get proper ray diagram. Okay, it is mandatory that CF should be equal to FP in your diagram. What is that? CF should be equal to FP. distance between C and F should be equal to distance between F and P. So you should mark those points not randomly. You should mark the point with scale. You should mark it properly. If it is 3 centimeter, this one should be also 3 centimeter. Unless and until if you are not doing it, you are not going to get proper diagram. Sure. Okay, so that thing is a mandatory thing. That thing is a very much mandatory thing. Okay, you got it. Okay, so here is the ray diagram which I have already taken. Okay, so here I have drawn it before because we need to, like, I will explain the ray diagram. Okay, so now here listen, focal length is 15 centimeter, right? So and object is placed 10 centimeter. It is obvious that image is placed within the focus. That's why the image is placed within the focus over here. So when the object is placed within the focus, first incident ray, there should be 2 incident ray for completing a ray diagram. First incident ray should be taken parallel, which is passing through focus. Okay. Second incident ray, here it is taken, like I have already mentioned in the last class, connected head and the nearest point. Nearest point is P. So connect it will be symmetrically reflected. So when we are extending it, it will not coincide at this side. So we virtually extend it. We virtually extend it, and here they are meeting. So there will be an virtual image formed. There will be a virtual image formed. Okay. So that you will be getting the ray diagram as well. So that they will be getting, you will be getting the ray diagram as well. Okay. Okay. Fine. Next question. Okay, a concave mirror produces 3 times enlarged image of an object placed at 10 centimeter in front of it. Okay, so calculate the radius of curvature. Here the question type is same. I mentioned before there are 2 types of question, FUV, and M. Out of these 3, any 2 will be given. Out of these 3, any 1 will be given, and magnification will be also given. So these are the 2 types. Okay, so this question we have already explained today, and this one also we have explained today. So these are the 2 types of numerical which is asking from mirrors. Okay, for I have already explained here in this question. Here what is given, and concave mirror produces 3 times enlarged, M is equal to 3 enlarged image of an object. Whether it is as it is enlarged image concave, we can take it M is equal to 3. Okay, then placed in front of it. So U is equal to object placed in front 10 centimeter in front of it. So U is equal to minus 10. Okay. So whether M is positive or negative, here M is positive or negative. So concave mirror it is, right? Yeah, concave mirror. So concave mirror gives both virtual image and real image. Both virtual image and real image. Okay. So here 3 times magnified it is. Okay. So we can take it like positive 3. M is equal to positive 3. Okay. So because it is virtual image which is formed by it, then M is equal to positive 3, U is equal to negative 10. So repeat the same thing. What is the step? Minus V by U is equal to 3. V by U is equal to minus 3. V is equal to minus 3U. So follow the same method that you have followed for the previous question. You can substitute in the mirror equation. Instead of V, you should write minus 3U. So you'll be getting the answer. Okay, so I'll give you the answer over here, and you can finish that homework, cross check your answer, because this is the same kind of question that you have discussed. Okay, so you should take it as a practice question. I'll give you the answer. The answer for focal length you will be getting F is equal to, after calculation you will be getting F is equal to minus 15 centimeter, and radius you will be getting minus 15 into 2, so minus 30 centimeter. So these are the values you are going to get. These are the values that you are going to get. Okay, so please take it as a practice question and follow this question. Okay, so you just copy the question. I either take a screenshot, and after once the live session is done, you can take it the question. Okay. Okay, now we are moving to the second part of this chapter, this refraction. Okay, I don't want to explain like what is refraction and all, as you are already aware about. Okay, I just want to mention 2 things regarding refraction. Directly moving to RDT and DRA. Okay, so what is RDT and DRA? My my Fahel and Jerib students may be aware about it. Salmi students will be aware about what is RDT and DRA. Okay, so listen, RDT means when light enters from rarer medium to denser, light ray deviate towards the normal. So not to by heart it. Okay, there is no other way. You have to by heart it. Rarer to denser towards normal. When the light ray entering from rarer medium to denser medium, it will deviate towards normal. So for that we have make a code, right? So it is just like interface is there, incident ray. We have to draw the normal. If the light ray is coming from rarer medium to denser medium, the refracted ray is there. This is the actual path of the refracted ray. Okay, this is the actual path. Okay, this is the actual path. Okay, so as it is entering from rarer to denser, it should deviate towards the normal. This is the normal, right? So this is the actual path. From it should deviate towards the normal. So this is how the reflected ray, refracted ray look like. This is the actual path. From this actual path, it is deviated towards normal. That is towards normal. So if it is traveling denser to rarer, it is traveling denser to rarer. So for that, the next code is the denser to rarer away from the normal. DRA. Denser to rarer, it moves away from the normal. This is the actual path, right? So it should deviate away from the normal. This is the actual path. This is the actual path of the light ray. This one is the actual path. From this, it should deviate away. Here is the normal, so it should deviate away from the normal. So like this you will be getting. So this is the direction of refracted ray. So denser to rarer, rarer to denser. What are the code? RDT DRA. RDT DRA. RDT means when light ray traveling from rarer to denser, when deviate towards the normal. When light is traveling from denser medium to rarer medium, it is deviate away from the normal. That's it. Okay. So loss of refraction. Okay. So what is loss of refraction? There are 2 points. First point is just like the angle of incidence, angle of refraction, and normal at the point of incidence to the interface are lying in the same plane. That is the first point. What is the second point? What is the second point? Second point is called Snell's law. What is second point? Second point is called Snell's law. Okay, so Snell's law we need to explain over there. What is Snell's law? The ratio of sine, while writing, don't write sin sine, that you know mathematical function sine, but you are writing in words in the definition. Sine is sine sine. Okay, so sine sine in words, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given for a given color and for a given pair of medium. Okay, so this part is okay, fine. If you are not writing this also, you will be getting marks. The ratio of sine of angle of incidence to sine of angle of refraction, is a constant. Ratio of sine of angle of incidence, sine I by sine r, sine I by sine r is a constant. That constant is called refractive index. That constant is referred to as refractive index denoted by letter small letter n. Or some of the teachers are following like the Greek alphabet mu. That is also fine. Refractive index mu or refractive index n. Okay, so refractive index is a measure of speed of light in that medium. Refractive index is a measure of speed of light in that medium. So no medium will be having refractive index less than 1. Okay, it will be always greater than 1. Okay, so refractive index of a medium is a measure of speed of light. If refractive index is more, speed of light is less. Okay, so the constant n is called refractive index. Okay, so now we can define refractive index. Okay, so here we are going to define relative refractive index, absolute refractive index. Okay, so here actually the equation is sin I by sin r is equal to n2 by n1. That is actual equation. What is n2 by n1? Okay, so here there should be 2 medium, right? So medium 1, medium 2. For first medium there is n1 as the refractive index, and for second medium its refractive index is n2. Refractive index is n2. So sin I by sin r. What is sin I? Sin I means if incident ray is here, this is I and this is r, as you know. So sin I divided by sin r is n2 divided by n1. n2 divided by n1. Sin I by sin r is equal to n2 by n1. So in detail you don't want to discuss with, but anyway we can calculate n2 by n1 using an equation. So n2 by n1 means speed of light in first medium divided by speed of light in second medium. That is, speed of light in first medium we can take like in medium 1, speed of light is v1, in medium 2, speed of light is v2. So when they are traveling from one medium to another, its speed changes, its wavelength changes. Speed changes, wavelength changes, but frequency remains the same. When light is traveling from one medium to another, its speed changes and its wavelength changes, but its frequency remains the same. So changes means it's not a drastic change. There will be change for a small little bit amount. Okay, so light will be having different speed in different medium. So refractive index n21 we can write. N21 means n2 by n1, but in terms of velocity it is v1 by v2. So I should write n21, right? n21 means n2 by n1, but in terms of velocity it is v1 by v2, v1 by v2. Just hold over the equation. How we are getting the equation is not important for us. Anyway, we need to mention the n2 by n1 is equal to v1 by v2, velocity of light in first medium divided by speed of light in first medium and speed of light in second medium. Okay, so here n12, n21, what is the difference? N12 means refractive index of first medium first with respect to second medium. N21 means refractive index of second medium with respect to first one. So definitely there will be some difference. N21 is equal to N2 by N1, but N12 is equal to N1 by N2. Okay, so are you crazy, sir? I am not crazy. The physics is crazy like this. Okay, not physics, not crazy. Okay, so don't be confused. N21 means N2 by N1, N12 means N1 by N2. That's it. What is N21? Refractive index of second medium with respect to first one. What is N12? Refractive index of first medium with respect to second medium. Easy. It's not crazy. Okay, fine. Okay, refractive index of second medium with respect to first medium, N21. Refractive index of first medium with respect to second medium, N12. Easy. Okay, so this is what is called relative refractive index. What is called? What is called? Relative refractive index. What is that? We are going to define two terms, relative refractive index and absolute refractive index. Is like you are supposed to by heart this definition. You are supposed to by heart this definition. This is the most important repeated question. Okay, out of this different set, you can find this question anywhere in that question paper. Okay, for board exam. Okay, absolute refractive index and relative refractive index. Okay, either your model exam, pre-board exam, which is happening in your school. Okay, you can expect this question. It's very much important and helpful for you in upcoming years as well. Okay, upcoming years, those who are going in science stream definitely will be help you. Okay, so relative refractive index. Okay, so relative refractive index means refractive index of a medium with in relation with another, that is relative refractive index, but you need to make it as a definition. Refractive index of a medium with respect to another medium is called relative refractive index. Example, refractive index of second medium with respect to first one, that is a relative refractive index. Okay, so N12 refractive index of first medium with in relation with this second medium, right? So N12, N21 are relative refractive indices, not indices. Okay, so refractive index of a medium with respect to another medium is called relative refractive index. Refractive index of a medium with respect to another medium is called relative refractive index. Okay, so what is absolute refractive index? Absolute refractive index is nothing but if the second medium that you are considering is air. Okay, if the other medium, refractive index of medium with respect to air, that is absolute refractive index. Okay, so refractive index of medium with respect to air or vacuum. Vacuum is also fine. Refractive index of air or vacuum or air, anything is fine, because in air and vacuum light is having almost same speed. Vacuum will have the most speed, which is 3 lakh km per second or 308 meter per second. But when it comes to air, it is light lower than that one. But anyway, in calculation, we can take like speed of light in air and speed of light in vacuum are almost equal. Okay, so the refractive index of a medium with respect to vacuum or refractive index of a medium with respect to air is called absolute refractive index. Okay, so usually in numericals, refractive index of a glass is 1.5, refractive index of water is 1.33. Like that will be given, which means the value which is given is absolute refractive index. So you will be having a full name, right? Okay, so my name is like full name is Rahul Raj, but no one usually call me Rahul Raj. Everyone call me Rahul. Okay, so similarly here absolute refractive index is there, but when we use it, we'll be simply calling it as refractive index. Okay, so Rahul means it is Rahul Raj. Similarly, absolute refractive index. Instead of that, we will be calling refractive index. So if someone is saying refractive index, what the content inside it is absolute refractive index. They are meaning absolute refractive index. If they want to specify relative refractive index, they should specifically mention it. It is relative refractive index which is given. Okay, and in other situation, if they are simply writing or simply saying refractive index, we should take that refractive index they have mentioned is absolute refractive index. Okay, so relative absolute refractive index is also called refractive index. Okay, so many terms, so many definitions. Okay, don't be confused. Relative, just simple as this, relative refractive index. Refractive index of a medium with respect to another medium. Refractive index of a medium with respect to another medium is called relative refractive index. Absolute refractive index, refractive index of a medium with respect to vacuum or with respect to air is called absolute refractive index. Absolute refractive index is also called refractive index. That's it. Definition is pretty important, pretty important. Okay. Okay. So speed of light in vacuum itself considered as speed of light in air. So speed of light in air or vacuum we can take like C. Okay. So the equation for absolute refractive index N is equal to speed of light in air, that is P, that is C divided by speed of light in medium V. So N is equal to C by V, N is equal to C by V, N is equal to C by V. Okay, you find it? N is equal to C by V is the equation. N is equal to C by V. You got it? Okay. So refractive index equation is C by V, speed of light in a medium, speed of light in air divided by speed of light in vacuum. Okay, next one. Okay. Question: a ray of light falling obliquely, so for the refraction to occur, light should fall obliquely. It will not happen for normal incidence. What is normal incidence? The angle of incidence is 0. That is what is called normal incidence. Okay. So all the other cases it is oblique incidence. Okay. So a ray of light falling obliquely from air to glass slab as shown in the figure. What is the angle of incidence over here? Can anyone answer this question? Can anyone answer this question? What is angle of incidence here? Angle of incidence here. Yeah, I have seen when I given this kind of question to some of the students, they are immediately answering, sir, 30 degrees the answer. Sir, 30 degrees the answer. No. So those who are having that kind of attitude, just read the question carefully. What is angle of incidence? Angle between incident ray and normal. This one, that is total is 90 degrees, 90 degree minus 30, it is 60 degree. So angle of incidence is 60 degree over here. Angle of incidence is 60 degree. Angle of incidence is 60 degree. Okay, don't lose it. Okay, where the angle of incidence is greater than the angle of refraction in this case. Angle of incidence is greater. Angle of incidence is 60 degree and angle of refraction is 30 degree, 33 degree. Okay, hey, what is the answer? Okay, so here light is traveling from air to glass. Light is traveling from air to glass. As you know, air is rarer medium, glass is denser medium, right? Air is rarer medium and glass is denser medium. When light is traveling from rarer to denser, it deviates RDT. What is RDT? Rarer to denser towards the normal. Rarer to denser towards the normal. So it will deviate towards normal. So actual path is supposed to be like this. My bad. Okay. Board is also playing with me. No. Final. Yeah, got it. Okay. So this is actual path of the light, right? Actual path. If the light, there is no medium interface. There is no interface, it will be go like this. But as there is separation between two medium, air and glass is there. RDT here, little deviate towards the normal. Deviate towards the normal. Normal is here, right? Towards the normal it is bended. So as it is deviating towards the normal, angle of refraction is less. So you can write the answer for this question. Why the angle of incidence is greater than angle of refraction in this case? Because it is traveling from air to glass, which is traveling from rarer medium to denser medium. So it will deviate towards the normal. Refracted ray deviate towards the normal. Fine. You see. Okay. Again, that kind of question is right. Okay, which of the given medium is fastest medium of light, or medium A and medium B? Okay, light is traveling in this direction, right? This arrow mark which is given, I don't know whether it is visible in your screen. Okay, so from medium A to medium B it is traveling. Okay, so which of the given medium is fastest medium of light? So how can we say that it is, which is the fastest medium? Okay, you should apply RDT-DRA concept. What is RDT-DRA concept? That kind of concept is not there in textbooks, sir. RDT-DRA. Okay, it's not there in the textbook, but in our classes is there. RDT-DRA. What is RDT? Okay, I don't write this RDT-DRA things in your exams. Okay, so this is for just our tricks and tips to by heart or to make it learning easy. Okay, don't write any kind of these abbreviations or any codes in your answer sheet. That code you should keep in your mind. Okay, so RDT here. So here, light traveled. Actually, it should travel this path, and instead of it is deviated. It should travel in this way. It should deviate towards normal, right? So it is RDT. So RDT means it is traveled from rarer medium to denser medium. So rarer medium to denser medium. So fastest medium is the rarer medium. So medium A is the fastest medium of light. So you should answer in such a way that as the light ray deviate towards the normal, you should write it. Okay, as the refracted ray deviate towards the normal, this light ray is traveling from rarer medium to denser medium. So medium A is the rarer medium. So it is the fastest medium. You see, justify your answer. Justification what I have mentioned right now. So first one you can write A is the fastest medium. Reason, justification, the light ray deviate towards normal. So which means it is traveling from rarer medium to denser medium. So medium A is rarer medium. So it is the fastest medium. Okay, rarer medium is the fastest medium. Okay, last question for today. I was supposed to take like the image formation. Okay, so spherical lenses that we can take in next class, and next class we can wind up the session, wind up this chapter. Okay, by mentioning about powers and all. Okay, now this is an important question. Refractive index of a diamond is 2.42. Refractive index of diamond is 2.42. What is the meaning of this statement? What is the meaning of this statement? Yeah. Sir, we know how to define refractive index, but refractive index value is 2.42. How can we define 2.42 value over refractive index? Okay, just is like conceptual question. Okay, overthinking not required. Just normal thinking is enough. Okay, so here n is equal to refractive index is 2.42. What is refractive index? We have n is equal to C by V. Okay, so C by V is equal to 2.42. So write this equation in words. Answer is done. Write this equation C by V is equal to 2.42. That answer is done. So answer is done. Believe me. Write this in words. How can you represent this in words? C by V means ratio of C to V. Ratio of C to V. Ratio of C to V is 2.42. Just expand it a bit more. What is C? Speed of light in air. What is V? Speed of light in medium. So the answer is done. The ratio of speed of light in air to speed of light in speed of light in medium is 2.42. So refractive index is refractive index of diamond is 2.42, means the ratio of speed of light in air to the speed of light in diamond is 2.42. The ratio of speed of light in air to the speed of light in diamond is 2.42. That is the answer. In another way also you can write. Okay, so C is equal to V into 2.42. So that is also another statement. Speed of light in air is 2.42 times speed of light in diamond. Second statement. How easy it is. Make it in this mathematical form in words. What is C? Speed of light in air or speed of light in vacuum. Okay, speed of light in air is equal to 2.42 times speed of light in diamond. V is speed of light in diamond. Okay, 2.42 times speed of light in diamond. You got it? So speed of light in air is equal to 2.42 times speed of light in diamond. Okay, another one we can write is like yeah, C by 2.42 is equal to V. That is 1.2 1 divided by 2.42 into C is equal to V. So write this in this in this mathematical equation in words. How can you make this mathematical equation in words? Listen carefully, listen. What is V? Speed of light in diamond. So speed of light in diamond is equal to 1 by 2.42 times speed of light in air. That is also definition for the answer for this question. Speed of light in diamond is equal to 1 by 2.42 times speed of light in air. Done. Okay, so you want to write this answer means yes, I have capability here. I know you will ask. Okay, just follow this. Just follow this. This is the answer. Refractive index. It is defined as a ratio speed of light in a vacuum to speed of light in medium. It is denoted by with n. N is equal to c by v. That is also one of the answer. Okay, the above statement means that speed of light in diamond is 2.1 by 2.42 times speed of light in vacuum. 1 by 2.42 times vacuum speed of light in diamond. Same thing. Okay, next one. As the refractive index of the diamond is quite high, speed of light in diamond will be reduced by the factor of 2.42 as compared to the speed of light in air. That is also another answer. Okay, so basically you can make these three box equation into words. What is the first one? I'll repeat once more. After that, I'll be going to wind up. Okay, so ratio of speed of light in air to speed of light in diamond is 2.42. That is the first one. You read. If you are not able to write it, just hear it one or two times. You can replay it. Okay, then you write it. Okay, that's the first answer. Second one, speed of light in vacuum is equal to 2.42 times speed of light in diamond. That is the second answer. Okay, third one, speed of light in diamond is equal to 1.242 times speed of light in air. That is the third answer. That's it. This is answer for this question. Quite easy. Okay, so I am going to wind up this session. Okay, so next class I'll be coming with spherical lenses. Spherical lenses, the terms associated with ray diagram and a little bit numericals and some definition for powers and all. And so that we will be winding up this chapter. Okay, so see you in next class. So the upcoming day, your Anila ma'am will be coming with another chapter. I think it's arithmetic progression. So see you next week. Bye bye.